Hey guys, we're back in the shop with the HW40 by FoxAlien. It's a hot wire foam cutting machine. It's the latest addition to the FoxAlien lineup. And today we're going to go ahead and do the assembly and a first test cut on this machine. So in this picture of the manual, we've got X1 as labeled on the stepper motor here on your right hand side, and X2 over here on your left. And then as far as these front and rear brackets go, you need to make sure that we have the holes, the offset hole lined up. And it is a little bit tough to see that on this page, so I'm going to skip over to this next page where it does show the next step. And we can see that the offset holes need to be over here on the left hand side, so I'm going to go ahead and flip that over like this. And over here in the front, we also have this LED light strip. And here we've got the holes that are over here on your left-hand side. And then we're just going to attach those with the 8 pieces of M5 by 20 screws that are in the parts box. It does come with an Allen head screw for that, which is convenient. But I kind of prefer to use this other one I have that has a ball end on it, which gives me a little bit more flexibility to the angle. And then as we install these, it's just a matter of sliding the screws through these provided holes. I like to run it backwards a turn or two just to get it started. Make sure that I'm not cross-threading the threaded aluminum that's in there. And there are additional screws to mount from underneath, so I'm actually just going to snug these up, not get them too tight. Now again, on this back one, we want to make sure that the holes are mounted down and on the left hand side. Over here on this front left side, we've got this label that shows us the movement of the machine. How on this hot wire machine, Y is up and X is towards the rear. This is a little bit different than your normal CNC machine because it's oriented in the way that the material would normally sit in the machine. So Z is actually the rotational axis, which is optional. So if you're only cutting 2D designs, you don't even need to use the Z axis. So Y is upwards and X is towards the rear of the machine when you're operating. And that will come in handy to keep in mind later on when we actually operate the machine. So our next step in the assembly over here on page 6 is to install 4 M5 by 10 button head screws as well as the leveling feet. Now you do have to flip the assembly over to accomplish this, and you'll notice that if you install the leveling feet first, it's extremely difficult to get the screws in. So I recommend starting with the screws and then installing the leveling feet second. Since I did leave these kind of loose, these end plates over here, that makes alignment of the button head screws in these holes a little bit easier. So we're just going to install this button head cap screw here. And again, I'm going to start with rotating it the incorrect direction to make sure that the threads line up well before bringing it down into place. And again, just like this one, I'm going to just snug these without getting them too tight. That's when we can come back and tighten down the M5 by 20 that we installed in the previous steps around the perimeter. And then we can install the supporting legs. Now these do look like leveling feet, but they're not really here to level the machine. They're just here to lift it up enough to provide clearance to these motors as it drives around. And then using the wrench provided, we can snug down these nuts on the back that lock them in place. Now moving on to the next step, we have the rotary axis profile here, and that goes into these two offset holes. And that's why it's kind of important to make sure that they are both in line and on the correct side, because if you do have them either out of line, this bar won't go in, or if they're on the wrong side, then the next parts that will go on won't be in the correct orientation. Now we're just going to install the M5x30 hex head bolts. And just as before, we'll put these in place, run them backwards to align the threads, and just sort of snug them up until we get all of the rest installed. All right, with all 4 screws in, we can tighten this down. Now with that installed, we are done on the bottom here. We can flip this over. And the next step I'm going to do is measure from corner to corner to make sure that our frame is parallel. Got 29 and 3/8. By 29 and 3/8 on that corner as well. So that is nice and square. So this bar here being perpendicular is not as critical as the frame being squared. So the next step here is to install these front and rear clamp profiles on the machine, and getting the clamps on is a little bit difficult once they're in place. It is possible to get them on and off if you install these first, but it's tight to the edge over here. And we just have to loosen this sliding nut here on the bottom off of that thread, and then it goes right into the hole here. And it just slots in there. And then we can just tighten this down a little bit just to snug it in place so it's not moving around on us during the rest of the assembly. And we'll repeat that with the second bar here. So then we need to attach these bars to the sliding nuts in here using the 4 M4x16 screws. Each bar uses 2 screws. So we're going to slide those through the holes provided here. And there they are attached to the nut. And with those left loose, you can actually move them around. And then back over here at the front again, we can slide this front one here to the 1 centimeter mark. Line that up and tighten it down. Now I'm going to measure from the front to the edge of this bar here on both sides and just make sure that both sides are set evenly. So before moving on to installing the Y-axis, let's talk about the Z rotary. Now this motor installs onto this crossbeam here using these 2 M4x16 screws. And then this rotating plate mounts onto that Z stepper. And then in order to install this, we have to find the flat spot of the stepper. I'm going to place it in line with this one over here and align that with one of the set screws. And after tightening one down, we can rotate it 9 degrees and tighten down the second one. So this is the optional Z-axis rotary assembly. Now, there is one change that I might end up having to do to mine. I don't like the idea of having to install 4 screws every time for this assembly, so likely I'll drill 2 holes in this plexiglass. That way I can go down and get to those screws without having to remove the plate, making it a 2 screw assembly instead of a 4. And in order to disassemble, we're just going to loosen those set screws. The plate comes right off. We can then remove the motor, set that off to the side, and I like to put these screws back in place so they don't get lost. And that is how you install and remove the Z-axis assembly. So coming right back to page 10 of the assembly manual, we can install the Y-axis rails using the provided M5 by 30 screws. And those screws go right through here and into that frame. And there's no need to worry about squaring this because that cutout in the back bracket here does a great job at squaring up this axis. And we'll just repeat that process on the other side. Now, with those 2 installed, we are extremely close to being done with this assembly. So the next step is to install a crossbeam into each of these L brackets to hold the Y-axis nice and square, top to bottom. Now, you do notice that on the bottom of these, we've got these nut inserts that are already installed in the beam, so we just have to orient those so they're facing down, set that beam in place, and then using the M5 by 10 screws, I'm going to put that right through this L bracket and into that nut. I'm going to install these 2 by hand at first. And then tighten them down with this Allen head. Okay, so the next step in this process is to install the hot wire. So using the provided thumb screw, that is going to attach in here. It's going to route over this one, under this one, under this one, over that one, and to a spring using a second piece of ceramic over on that side. And these are the 2 pieces that we need. So the ceramic I've already installed onto the spring here, and this piece, which has a few little holes in it, and that's where our hot wire is going to route through and get tied off to this spring and to this ceramic. Now, I did catch a small typo in the manual that I have, and it calls for a 70 millimeter length of wire, and that is supposed to say 70 centimeters, which comes out to just over 27.5 inches. That measurement of 27.5 inches is after tying it off to the wire adjusting module and to the spring. So I'm just going to go ahead and twist this part while holding those in place. So then I'll measure out approximately 27.5 inches. It doesn't have to be that exact. We are going to use this wire adjusting module to take up some of that slack. So now with that cut to length, we can do a similar action here on the ceramic and the spring end, wrapping it through and around, and then just twisting the ceramic and spring. You can see we've got it twisted a little bit there. I'm going to twist it some more just to make sure it's tight. Hopefully you can see that. We've got about 6 or 7 twists on there and it's good to go. So the idea here on this end is that we're going to install this adjustment knob into this hole, and I am going to need to be able to rotate this a few times to take up that 27 inches of slack. So I'm just going to go ahead and install it loosely, just get about 3 or 4 threads in. Enough room that I can tighten this nut down. So right now it's flush with the back. So I've got full thread engagement, and I'm just going to stop there. So the next part is to run the wire over this ceramic piece, under the next one, across, over to this side here, where we're just going to repeat that process in reverse, under this lower one. You have to make sure that it does actually go in between the 2 different color ceramic pieces like that. Put that one there as well. And then here we've got this spring assembly. Now you can see I've got quite a bit of extra wire over here. I'm just going to use this knob to take up all that extra slack. So what I did there is I added a few turns to this to take up most of the slack, making sure that I had about enough room to run this wire over here and mount the spring. You see I don't have too much tension on it, so the wire will actually extend with heat. So we actually do want some tension on this from the start. So I'm going to turn the knob a little bit more. And you can see I've got some good tension on there. And I'm going to tighten down the locking nut now. Now holding that tension with the spring extended like that, I can go ahead and tighten down this nut. Now that nut does a great job to lock this in place, and now my spring will remain over here with tension on it. With the hot wire mounted, our next step is to route and connect the wiring harness. Now on the bottom of this bar here, we do have some zip tie mounts for mounting the wiring harness for the Z-axis. So we do need to route this wire and zip tie it in place for that portion of the assembly, and then work from there out. So we can rotate this right back onto its feet. Now with that Z-axis zip tied down the bottom there, we can move right onto the number 1 side, where there's a few more cables and connectors. So I'm going to start here with the Y1 motor. We've got clearly labeled connectors, just as with all of the FoxAlien machines. That one plugs right in like that. And then we have the X1 axis over here, as well as the home switches. So the X1 axis is again clearly labeled, and it snaps right into place. Now then, these might get a little tricky, the Y home and the X home. Now if you recall, our picture on the side identifies that the Y is the vertical up and down motion. So we're going to go ahead and plug this one into that Y limit switch. And the X is the horizontal motion. So we'll go ahead and plug the X into that switch. And they all snap right into place. We'll move over to the number 2 axis. So the Y2 axis connector into the Y2 motor here. And the X2 axis connector into the X2 motor. Now the next step has us routing these power wires up along this side over here. And it's going to get zip tied in place right there. And over the top as well. So here you can see I've run the red wire along this edge up over the top right here. And it's going to run down and right to the hot wire. So I've only loosely attached the top here with a zip tie. We'll do the bottom and this third zip tie point here as soon as the wire is attached. In order to attach the wire, I'm going to go ahead and loosen this screw. And then the wire is just going to go in between this brass washer and the steel base plate here. Now, as this wire heats up, the spring here will actually compress down. So we do want to give it enough space between these two that it definitely does not impact the ceramic part there as it shrinks from cooling. Since it is currently in its cool state, as long as we do leave a gap there, we should be fine. And repeating that same step on this side, running the wire up and over. So since this one may get tensioned later, when it does get hot, I do want to leave plenty of space between these two, but not so close that it touches the ceramic portion there. So we'll tighten it down right here. And it just needs to be snug to make sure it doesn't come off. So with that in place, I will add the remainder of the zip ties. So here we've got the back of the power supply module, and we have all of our perfectly labeled plugs here. And if we grab the LED cable from that front beam, we can attach the LED cable to that one first. Followed by YH is for Y home. XH is for X home. The next one is Z axis. We can attach that here already, even though we're not going to attach it to the motor right now. And the next one is Y1. Followed by Y2. Just going to flip these under for now. The X1 axis is next. And then the X2 axis. Now this last plug here is the power going to our hot wire. So it has a few extra flathead screws to attach in. And those are optional, but I of course will be attaching them in there just to make sure this is quite secure. And since we're here as well, let's go ahead and make sure that these are snug. So if you do have any issues with this power supply, there's actually a fuse right here built in. So we can pop this out just by sliding that out right there. We can take a look at that fuse. This is a 10 amp, 250 volt bus fuse. So let's talk a little bit about this controller that FoxAlien supplied. So over here on this side, we have a input power selector, 110 or 220 volts. It's actually labeled 115 and 230, but just switch it to your correct AC input voltage. In the United States, for most people, that's going to be 110 volts. In the UK, where 220 is more common, you'll need to select that. So we also have an e-stop, which you push it to engage. It's going to stop the motion and the power to the hot wire. So in case of an emergency, that's what you would press to stop those two functions. In order to turn it back on, if you do have issues with turning the machine on, just come over here and double check that the e-stop is not pressed. You can push it. And see right now, it feels like I'm just pushing a button, but it's not fully retracting. We need to turn it, and it will pop up. Now, as well up here on the front, we do have a voltage meter, which reads 0 to 30 volts. We have the voltage selector knob and the power on and off for the hot wire itself. That's what this portion here is. Now again, in the front here, we've got the USB cable, the optional offline controller, and a power light. Over here on the back side, we have the on-off power switch, the AC input power, and all the rest of the cables that we previously plugged in. So we finished up the assembly of this machine, and it's time to jump over into the software to get started on the setup for our first test cut. Over here on the thumb drive, we do have a copy of the user's manual and some assembly videos, and we've got some sample photographs in here that are also shown in the tutorial of how to use the software. These are just some silhouettes that you can use along with the video walkthrough to teach you to learn your first project. So we also have some test code in here and the actual user manual. It's in a digital format, and some software. We have Inkscape and UGS. So you'll need to install both of those. I've already gone ahead and done that. And we are going to skip Inkscape for now. I'm just going to jump into UGS, and you go over here to this bin folder, and we have UGS platform 64.exe. And you can copy that directly over to your desktop. Send to desktop, create shortcut. And I did say 64 because I'm running a 64-bit computer. If you're not running 64, but you have 32, you could run that version instead. I usually run a different G-code sender called OpenBuilds Control, and I have a quick little video about OpenBuilds over here, but instead we're just going to use UGS since that's what's covered in the manual for this and what's included on the thumb drive. So the first thing I like to do in UGS is to click this refresh port number in case it is set to a different COM port when it first opens up. And then when I click the connect button over here, it's going to connect to our machine. So we're going to go ahead and home the machine. After homing the machine, I'm going to go ahead in here and open one of these test cuts. And we'll start with the word Fox, which is a 8 1/4 by 3 inch cut. And you notice here it starts about an inch in. So I've gone ahead and put the foam in place. Now it's just time to turn on the heating element here. Set it to the recommended 25 volts. We are ready to send this job. All right, so the lesson on that one is that some of these jobs cannot be run from the home position. You notice here on the bottom of the O, it actually comes all the way down to the bottom of our XY for this project. And that just hit my lower Y homing switch and gave me an error. So I had to raise it up a little bit and rerun this program, and it's running just fine. So just keep that in mind if you do run the files from the thumb drive. At least this Fox one, you have to at least raise up the Y a little bit, or else it will hit the switch and fault out. All right, with that job done, go ahead and turn off the strip there. Give it a moment to cool. It only takes a few seconds to actually cool off. It's already cool to touch. You can go ahead and pull out. And there we have it. That's what we just made. Pretty neat. Now let's go ahead and run the rest of the jobs that are on this thumb drive and see how those all come out. Alright guys, thanks for checking this video out, and if you haven't already, make sure you hit the like button down below. It really helps. Make sure you check out this video next.